Sum and difference. I hope this makes sense too. If you had two different, and we've already worked on this before, if you have things added together, you can break them apart and evaluate their integrals separately. Notice this constant multiple. This is for a constant, like a number. Does this say f of x and g of x? No, you cannot take two functions that are multiplied at this time, because what you're doing is, going forward, we have a word for that, product rule, right? And when you took the product rule, what was it?
What?
What's the product rule when we were doing derivatives?
First he said yes.
So if we're going backwards, you can't, you have to take a first d second, second d first to go backwards. That's a whole thing, that's a whole nother thing. And yes, Julia, yay, we're going to do it. But not yet. You can't go backwards from just a fx, gx. You can't go backwards by just, trying to find those integrals separately. Only with a constant. You can do it with sum and difference. You can add things together. The additivity I like to think of as this. I am a visual learner, so bear with me. Let's say I have a curve. A, B, C. Okay? If I did from A to B, that would be the integral of A to B f of x. Agreed? Now, in blue, bam, bam, what's that I just highlighted?
B to C.
B to C fx dx. If I put those two together, what would that be the same as?
A to C.
A to C fx dx.
That makes sense.
Make sense? You can use it and also go backwards. Like if you have the whole thing and you have one of the pieces, you could subtract them to find the other piece. Okay? Oh, it is not. Let's try some. Let's see. It's too easy. Letter A, example 1. I give you some information in the problem. What do you think that is? What rule am I using here? I'm yelling at you?
No.
Oh. What? Sum and difference. I can just add 2 to 6 of f of x plus 2 to 6 of g of x. Am I given both of those integrals? You are. So what would it be? 10 plus negative 2 or 8? Julia, focus please. What should I do to evaluate that? Yep, I'm given this, negative 2 minus the integral from 2 to 6, which is 10, negative 12. Keep going. Which one is C? Which rule is that? Constant rule. I can take a 3 out to the front. You're given the value for 2 to 6 fx dx. It is 10. So it's just 3 times 10 or 30. 6 is additivity, and we can still break it apart. But you can find the second part by using area. So this would be 2 to 6 fx dx plus 2 to 6 2 dx. What's this one? 10. Using area, this is a flat line at 2. If I went from 2 to 6, what would be the area under that curve? Yeah, 4 times 2 or 8, right? That would be 18. Julia, ask a question if you're confused.
I don't know how you split that one
I split this one up because according to these rules, if I have two functions added together or subtracted, I can split up their sum into two separate integrals. That's what I was doing here. It's just that I gave you both of those. That's what I was doing here, but I gave you both of those. That's what I did here. I gave you this one, and we can do this one using what we used last unit, or last section.
So how do we know what
You graph the line y equals 2.
to Oh.
Oh. Can I move to the next page yet? I got some new pens in the mail yesterday. I mean, they didn't just arrive, I ordered them. So this is, yeah, I got some green. Trying out a new kind. They're okay. Don't mind them. Let's try this one. So this time I give you some different information. So I give you 0 to 5 of f of x dx is 10, and I give you 5 to 7 of f of x dx is 3. So my question is, what's 0 to 7 of f of x dx? What can I do? Well, I'll just show you what I'm doing here. I can add 0 to 5 fx dx, because plus, this is the additive rule, 5 to 7 fx dx together, because those two things together should give you this. And what are those things? 10 plus 3, or 13. Okay. Let's look at B. Ooh, if you need to look back, you can. If I have asked for 5 to 0, that's the property of limits of integration. That's going to be the same as the opposite of 0 to 5 of f of x dx. Okay, so this becomes useful, especially later on, when like I give you pictures with area and I give you it the other, like I ask for the integral going the other way, so you can find, whatever, you'll see it in a second.
How does that look like graphically?
Well, it doesn't. This is hard. You can't, graphically, you think of it as this. You find the area from 0 to 5 and make it the opposite. That's what I
Well,
mean
I don't
with this helps.
understand if it's
Yeah.
above the curve, then it's always positive. If the above the curve goes way.
Reversing the endpoints of integration is going to change the sign of whatever the integral is. So if it's negative, it would become positive. If it's positive, it would become negative. Not 5 to 0 basically says you're going backwards. That makes the integral negative. There's no always
No, I mean, if
in
it's
calculus.
We need to draw a picture.
I mean, if
I
it's
can
like
with area in a
above
second.
the-
Okay, let's finish these and then I will be happy to draw a picture. This would be the opposite of 10. What's 5 to 5 f of x dx?
0.
0, easy. How about this one? Pull a constant out to front. 3 times 10 equals 30. Okay.
How'd you get 3 so easily? Oh, you don't have to, I thought you have to like imagine a graph of,
That's if it was 3 plus f of x. This is basically think of this as 3 times the area. What if I made the area 3 times as big?
okay.
Okay, here's my curve f of x. Okay, let's write down some things. This is 0, 1, 2, 3, 4, 5. I'm trying to make it a confusing one. So if I asked you, what's the integral from 0 to 5 of f of x dx, you would tell me
1/2 base.
1/2 base times height, but it's below the x-axis, so we make it -3 times 15, okay? -7.5.
Oh.
Okay.
come on.
So if I flip around the endpoints of integration, and here's where this becomes a thing, because sometimes the AP will tell you one of these, and then you have to put it together with an area of another piece. So that just becomes a useful thing if you can get just real good at flipping the endpoints. If I said, hey, what's the integral from 5 to 0? Okay, you're essentially, there's no graphical way of saying this, but basically I'm undoing this. So if I wanted to undo this, it would go up there. It would become positive 7.5. It's when you flip endpoints around, they're the opposite of the integral. It doesn't really matter if one's negative and it becomes positive, or positive and negative. Don't get caught up in that. Just know flipping endpoints of integrals just changes the sign of the integral.
That's silly, it's negative. So you're saying it goes above the x-axis now?
I'm saying there's no way to represent this with area because this doesn't make sense.
Oh.
Because you don't start at
You're
5. If you want to think of it as reversing and going backwards and undoing this, you can, but that's the only way I would say
I
graphically it
was
would make
thinking
any
of this
sense.
like, it's not negative left or right. You know what? I'm not gonna explain it.
Okay, you're just going to explain it in your head.
Yeah, I'm just explaining it.
So tomorrow I would like to talk about average value of a function. This is a very important thing, so I'm going to reserve that for tomorrow. The average value of a function involves the integral, but basically if you graph a function, not an integral, there's a way with integrals you can figure out what is the average value that the function attains on a certain interval, and it relates to that. I don't think I asked any questions like that until tomorrow. Oh, I did. Oh, yeah, I asked. Hold on. 5. We got to go through 5 today. Then. Okay. Homework. I'm changing this up. You're doing your worksheet and you're doing questions 1 through 5.
Are you changing that in the calendar too?
I will do it right now. Okay, Cole, you good? In the hood? All right.